Welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, January 27th. Looking at significant wave heights, we see a gale developing in the West Pacific with 44-foot seas aimed to the east, aimed well at Hawaii and the U.S. West Coast, and this system is expected to build even more. Otherwise, we have a rather placid pattern in the eastern Pacific. Yes, a little bit of wind swell being generated relative to Hawaii, but nothing of any particular interest. Let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, it helps direct their track. We're looking for a dip in the jet, just like that right there. That dip, see the jet pushing to the east off of Japan. That little dip right there helps create an eddy in the jet stream in the upper level flow there, which creates a counterclockwise circulation. Counterclockwise circulation in the northern hemisphere is the hallmark of low pressure, and it also does that down at the surface. And of course, low pressure at the surface generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a decent bit of a trough here, and as we saw in the previous chart, yeah, we know there's low pressure developing here, and seas as well. Now the jet, it kind of looks like there's another trough developing here off of Hawaii, but what's really happening, the jet is kind of splitting with part of the energy pushing up into up into Alaska, most of it pushing south over Hawaii and eventually down towards the equator. When you have a split flow, as you see in a couple of frames from now, that really is the hallmark. You know, you get high pressure in between the two branches of the jet, and that's what's really going on off of California right now. So let's put this into motion. Here we go. You can start to see it's like there's a brick wall right here, and the jet can't make it past there. It just doesn't have enough energy to dislodge this high pressure, this blocking high pressure. So what you end up with is beautiful sunny weather in California and warm temperatures and light offshore winds, not so bad, while all the storm production occurs over here in the West Pacific. So here we are, Monday night. Jet's still looking pretty solid. Still have our trough off Japan. Winds, what is that, about 160, 170 knots over Japan, but less are out towards the dateline. Split point at about, let's say 160 west, something like that. And we'll just go out another day or two. Now you really see the split flow, the northern branch pushing up into Alaska, the rest down towards Hawaii here. New trough develops on Wednesday morning right there, being fed by 180 knot wind. So the more wind pushing down into this side of the trough, the better to get that counterclockwise circulation going. So this looks like a pretty decent trough here again. So the second trough on Wednesday, we'll roll this out, and you see it gets pretty well developed, still being fed by 180 knot winds into Thursday, and even up to 190 knots into Friday, but the trough starts washing out. Now notice, a little bit of a trough starts developing. Because the split point's so far west, over about 160 west, the jet goes up, and then it starts falling down. You get a little bit of a trough here. That might usher in some precipitation to the U.S. West Coast, maybe help to start breaking up the high a little bit, the blocking high pressure pattern. You see the trough pushing right over Northern California on Friday night. Oh, and there we go. We lost our data air, so it's kind of hard to see what's going on. But you can actually look at the upper level ice bars, see upper low pressure here still over the West Pacific, and that pattern continues out a week. I know, that's not a good picture. Bad data. When we get the 0Z run of the model, that'll all clean itself up. All right, next stop. Let's take a look down at the surface. What's going on? No big surprise. Gale low, actually a storm. 50 knot winds. 50 knot winds are the minimum threshold for a storm. And 45 knot winds over a pretty good sized fetch area aimed off to the southeast. These northwest to west winds here, targeting Hawaii, the U.S. West Coast. Not bad. And as we get, now notice, it's lifting northeast. So the fetch is all, again, almost starting to bypass Hawaii as we get into Monday morning, targeting the U.S. West Coast better. Great circle tracks, not exactly a straight line over distance. It's actually more up like that. We can maybe take a look at that later. Anyway, 50 knot winds. The gale redevelops on Monday. Storm. 50 knot winds continuing through the day Monday, and then pushing up towards the North Dateline region, fading out as we get into Tuesday. Another system comes in right behind, 45 knot winds, but that one sort of fades out, not looking as good, but sort of this fragmented 30, 35 knot fetch thing going on into Thursday, and then what happens? Interesting. Just kind of a nondescript pattern. I mean, 30, 35 knot winds from this far away. Yeah, they'll generate swell, mainly for Hawaii. You're looking at 13, 14 second, maybe 15-second period swell, but not, you really want stronger than that. Oh, and let's go back. Let's see. There we go. There, I'm looking right here. There's that little low pressure system forecast off California on Friday into Oregon and Northern California. Then maybe another little system on Saturday night into Sunday. But still, here's that. Remember the jet coming, sort of digging down like that, and then splitting, part going up here, part going down there. There's your bulletproof 1032 millibar high sitting off the U.S. West Coast. As you get into the weekend, north winds likely in control, and all thanks to the split jet. The assumption being the active phase of the MJO is over in the West Pacific on the equator, like right down in this region. That's feeding the jet north of it. But the inactive phase would be like over in here somewhere, and that steals energy from the jet, and so the jet splits. So just something to, the MJO kind of dictates what the jet's doing over the Pacific. All right, wave model charts. We're going to go back in time just a little bit to Thursday. What's that, like three or 4 days ago? Small system pushed off Japan, built 31-foot seas. Did it get a little higher? There we go, 32-foot seas. There's max seas over this entire domain, 33.3 feet, and winds in that area were 46 knots. So that's a quick little cheater way of looking at what's going on. And then pushed off to the dateline and died on Saturday. Swell from this system, you can almost see it. It's right there, getting ready to push into Hawaii come Monday. And then here's our newly developing system. And so here we go, looking at the forecast now. We saw, what was that, 43-foot seas being generated right now. Now we know the low is supposed to push off to the northeast a little bit and then regenerate. And here you go, as we get into Monday, pretty nice size area of 46.6-foot seas. We'll say 45 to 46-foot seas. You get the sense, aimed more to the east than at Hawaii, but still swell for all locations. The storm makes it to the dateline and then starts fading out on Tuesday. Another weaker system behind that. I mean, you get the idea here. Storm after storm or gale after gale. Here we go, 32-foot seas. Wednesday fading out. And then that generic area of 35 knot winds generating, we'll say 25 to 30-foot seas aimed off to the east as we get into Sunday, and then also seas from local gale pushing into Oregon as we get into Monday, and there we go. So a steady stream of surf, one of those swells being a little bit bigger relative to Hawaii and the U.S. West Coast, but then the concern is when the swell really starts arriving in earnest on the U.S. West Coast, it looks like weather is going to start falling through in the Gulf. So let's confirm that theory. A little bit of look at local winds for the next week. Okay, right now, California, here we are, right there, Southern California, Northern California, Central California. Light winds. This isn't detailed down to your specific break, but it gives you a general idea of what the pattern's doing. Of course, this sort of cutoff low down here generating north winds into Hawaii, that just kind of makes a mess of everything along the north shore of most of the islands. We'll just sort of blast through this Monday. Still much the same, though. A little bit of more tendency of northwest winds rather than northeast winds for California. Good, strong, I guess you call it a cone of flow into the Hawaiian Islands. Not great at all unless you're on the South Shore and there's not really any swell there. Get into Tuesday, north flow, a little bit of weak high pressure builds here, building a little bit of more distinct northerly flow. Also notice developing low pressure Wednesday, the Gulf of Alaska. And then lighter winds, but look, it's a little bit of south wind starting to push into Northern California on Wednesday. North flow continuing for Hawaii. Thursday, that low, the initial low kind of washes out. You just get this sort of generic 10-knot northwest fetch. Northeast winds still for Hawaii, not good. Then the real system starts building off California as we get into Friday, looking pretty healthy. Southwest winds, likely precipitation, and the winds finally start turning to trades as you get into Friday. on Hawaii. See, the high starts pushing off to the east, and then so you get a clockwise flow around high pressure. That's what drives the trades over the Hawaiian Islands. So once the low clears out here, back to trades as you get into Friday, Saturday, but then things fall apart for the U.S. West Coast. Pretty much nuking north winds even down into Southern California on Saturday morning. Next system queues up behind that. Notice the high pressure, instead of sitting over here, is actually retrograded to the west. That's because the split point in the jet retrogrades more too. And you got your nice, more or less trades into Hawaii. As we get into Sunday, same sort of deal. Pretty much a mess on the U.S. West Coast, and there we are 180 hours out with a bulletproof 1036 millibar high sitting northeast of Hawaii. All right, let's go take a look at precipitation. All right, so here we are Sunday evening, that cutoff low, yep, and we're really looking mainly for precipitation for California and snow, but you see some rain potential for Hawaii as well. Nothing really happens. Little bit of maybe a fleeting, glancing blow of light precipitation along the coast as we get into Wednesday night, Thursday morning, but no significant snowfall or anything. But then the system starts building, pushing down the coast on Friday. That would be a colder core one. Snow into the Sierra by midday Friday, rain along the coast. Good, heavy snowfall for the Sierra as we get into Friday night. Rain along the coast, and that continues into about Saturday morning, backing off a little bit. Now, the next system, remember, high pressure, so the low falls down this side of the high, and then maybe another dusting or a little bit more of snow. So you get into Sunday, and then, and then that's where we are, 180 hours out. But it looks maybe even into Monday morning, some snow. Let's get into some details there. Snow dashboard. So we're looking at almost, let's say, 23 inches of snow. This is at Squaw Valley. Not even starting till the, February 1st, which is Friday night, Saturday morning, and more on the 3rd. So that'd probably be like Sunday, something like that. So pretty good. Now, this is the interesting part. Look at the snow levels. This is the top of Squaw Valley, up at Granite Chief Peak. This is down at the base. The reds, liquid precipitation, greater than 34.6 degrees. So, and if you really look at temperatures, I mean, for the past 2 to 3 days, it hasn't gotten below freezing at the summit up there, even at night. And that's generally supposed to be the case. But then as we get towards the weekend, remember we said high pressure off the coast, driving cold air down the coast. You see the snow levels plummet down to, and here is the actual snowfall. You know, you can sort of overlay it. So snow down to, what is that? The gray, we'll call that sleet, basically, around 3,500 feet, and even dropping at one point, supposedly down to 1,000 feet on February 4th. So pretty cold bump in the regime there. How about winds? Yeah, pretty windy. Not horrible, though. Below 60 knots, even up at the peak during the peak of this supposed storm cycle, so something to watch for. Of course, never believe the models this far out in advance. This is just preliminary guidance at best. Let's go take a look at Kirkwood. We're seeing basically the same profile. They're not that far apart, 25, 26 inches of snow. Again, the same very low snow levels, and more wind at Kirkwood, though, but also notice they're a little bit higher. Peak up at 10,000 feet, closer to the jet stream, you get more wind. So maybe some gusts in the 70, 80 knot range there at one point. So something to be mindful of. Let's go take a look at Mammoth. Since this is a northward falling system, less snow down south, it all gets wrung out in the Tahoe region. We're talking 11 inches of snow, and still reasonably low snowfall levels, especially Mammoth. Now, the base is at 8,000 feet, goes up to 11,000 feet, so you sort of get the idea. It's a lot higher, it gets a lot colder there. And winds, yes, winds a bit of an issue during the peak of this event. And just for last, in the San Francisco Bay Area, Mount Diablo. Now there, the snow level gets down to 4,000. This is the summit of Mount Diablo, right about 3,900 feet. And yeah, possible to get some sleet, maybe some flurries there, but nothing more. And then looking at the Grapevine, Southern California, this is the peak of the grapevine there, and just maybe a couple of windows there for sleet at best, not even freezing temperatures, 34.6 degrees, maybe 34 degrees at best. So probably not an event there. So with that, let's go take a look long-term. What's going on with the MJO? How is the MJO driving the jet stream? What's the forecast for the jet stream and the MJO long-term? And the probability for that split pattern to disappear and have the jet actually come pushing directly into the U.S. West Coast. And also what's going on with our supposed El Nino. All right, as usual, we like to start by looking at winds across the Pacific on the equator, because that's sort of where the MJO lives, specifically in the West Pacific and what we call the Kelvin wave generation area. From the area 135 east, that's New Guinea right there, there's the equator. The date line's right there. So to 170, 5 degrees north and south of the equator, draw a box right in here. This is the area we like to monitor. Now you see the sensors are down in some of this. You can see actual winds over the entire Pacific. This is from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. Also good for monitoring the MJO, though. East winds, trades, pretty much in control. Pretty solid. Maybe a hair bit weaker in the southern Kelvin wave generation area, but nothing too noticeable. But then we look at anomalies, differences from normal for this time of year. And you go, if the arrows are pointing either east or west, that's what we're concerned about, not north or south. What this says is if they're just sort of neutral like this, that means, yeah, these winds are normal. Maybe a little bit stronger out of the east than normal, or out of the west than normal, right in this one little pocket here, but really nothing. And maybe a little bit of a westerly tendency in the Kelvin wave generation area, but not much. So basically, a normal seasonal pattern for this time of year. So let's go see what's been going on for the past 5 days. Right, there's South America, there's Central America, there's New Guinea there, and the Philippines there, the equator, 0 degrees, right? Running, and so this is the Pacific right through there. Kelvin wave generation area, 170 west to 135 east. So draw a little box in your mind. If you see the blues, that means easterly anomalies. That means the inactive phase of the MJO. So January 21st, yeah, inactive, inactive, weakening inactive, weakening inactive. Notice the building westerly anomalies in the far west Pacific on the 25th. Sort of looks like there was an inactive MJO pattern in control, but that it's losing ground. And that's sort of what the jet stream looks like. But let's dig a little deeper. Let's look at the forecast. We've seen this chart before. Again, this is the whole planet on one page with the date line running right up the middle here. But the area, the Kelvin wave generation area, is pretty much 135 east. So from here to here, and you just sort of go right up, draw lines right up there in your mind. So what you see is these reds are westerly anomalies. So you can see we had westerly anomalies in the Kelvin wave generation area and pushing almost to California in the early part of January. And we definitely had some rain and storms. We also had a lot of surf and big waves off the coast. All that associated with what one would assume is the active phase, the MJO. Then notice here, easterly anomalies, the blues not really filling the Kelvin wave generation area, but sort of putting a dampen on the westerly anomalies. And one could say, well, that's the inactive phase of the MJO. But here we are now, and it looks like, wow, westerly anomalies are building, filling the Kelvin wave generation area, and expected to continue for the next week. That's good news. That maybe suggests the active phase of the MJO is setting up. All right, let's look a little bit further into the future. This chart goes out 2 weeks. Outgoing long wave radiation. So that's another way of fancy way of saying where are there clouds and where are there not clouds. Whereas there's this blue stuff, that's negative anomalies. That would mean no outgoing long wave radiation or less outgoing long wave radiation, meaning clouds, meaning low pressure, meaning the active phase of the MJO. So sure enough, as expected, active phase of the MJO building in the West Pacific, and per the statistic model, it's supposed to stay in the Kelvin wave generation area, moving to the date line 2 weeks out. The GEFS model is actually even better, saying it's supposed to build into the Kelvin wave generation area and stay solid there for, not even moving to the date line 2 weeks out. Now, this shows the inactive phase of the MJO in the Indian Ocean, but we also know there's something going on down here. But, the jet is splitting like right over right about where this ends. So you have energy to here and then a brick wall. So as this moves further to the east, the split in the jet will fade or move closer to California. Theoretically, that's the theory. This model suggests the split is to hold. Now, that's actually good for California in terms of, if you want high pressure and generally offshore winds, that's perfect. All the storms stay bottled up in the West Pacific, pushes swell towards Hawaii, the U.S. West Coast. They're basically protected by high pressure. But at some point, you're going to want precipitation too. Now, this is not saying absolutely that's the case, because we know for a fact there's modeled of a little bit of low pressure supposed to work its way into the coast a week from now. But for the most part, we're going to say high pressure rules supreme until the MJO, the active phase, starts moving east. All right, let's look further out. Actually, let's do it this way. Phase diagram charts. I want to know a little bit more detail. So assume, how do you read this thing? Assume you're looking down on the North Pole. The MJO moves from west to east, from the West Pacific to the East Pacific, under the United States, on the equator, across North Africa, into the Indian Ocean, over the maritime continent, back to the West Pacific, and it cycles round and round. Where the heavy dot is where the active phase is right now. No big surprise, in the far West Pacific. The further the dot is away from this circle, the stronger it is. So the ECMF model says, active phase, making it to the West Pacific, getting very weak, crashing, and dissipating. But the GEFS model says, no, it makes it to the West Pacific. Not only does it builds pretty strong. We're up here, the further away from the cycle, we're about I'd say 2/3 of the way to the highest, strongest active phase we've ever seen had some dots up in this region. So a pretty solid active phase of the MJO. Now, the two models are as weak as it can get to almost as strong as it can get. So who knows what's really going to happen? Probably somewhere in between. Moderate active phase, gurgling around for the next 2 weeks in the West Pacific. Probably the likely outcome. All right, the upper level model going out 40 days. Where the greens are areas favorable for precipitation. Where the reds are unfavorable for precipitation. So one could say active phase and inactive phase. Of course, there's South America. There's New Guinea, the Philippines. You got it, the equator right there. So active phase, according to this, and I think this is driven more by the statistic model than by the GFS model, suggesting active phase working its way into Central America, let's say mid-February. As the inactive phase builds in the West Pacific, it makes its trek across the Pacific, and we don't see another active phase until the end of February or so. And of course, when the inactive phase is in the Pacific, that's when you're more likely to get storms. When it's in the West Pacific, that's good for swell production. When it's in the East Pacific, better for rain production into California. And then the CFS model, same sort of deal. The whole plan on one chart, Kelvin wave generation area between these two tick marks going up. You can look back at past history here. The heavy black lines are the active phase of the MJO. When you have the active phase, you also tend to get these reds. The reds are westerly anomalies, and westerly anomalies help impart energy to the jet stream, feed it. And the further the active phase makes it across the Pacific, so in the early part, that's the swell production phase. When you get into here, California's at 120 west. That's the rain production phase, inactive phase, right? We're looking back in December, active phase, a little inactive phase in January. Now, where are we? Sort of indeterminate here. No heavy black line, but it looks like the active phase today is in the far West Pacific. We have westerly anomalies pretty much filling the Pacific almost. And the good news is, that pattern is supposed to continue through February 23rd with westerly anomalies pushing into the U.S. West Coast. So one would say that's probably the rain phase, probably we'll say mid-February to the end of February. And this is the swell production phase from now into about, February 10th or so. But that's just a very rough approximation, and these are very high-level models going out a month. But you can kind of get a sense and read the tea leaves up to a month or even more out. In fact, let's go look at another model. All right, so the CFS model going out 3 months, past history on the bottom, future forecast up top, Kelvin wave generation area between these two tick marks moving up. You can see right here we had a pretty good active phase of the MJO, westerly anomalies in the early to mid-January time frame. Probably this was the inactive phase. In fact, let's just overlay it. Boom, there you go. Inactive phase, the dotted contours. A light active phase building according to the charts through middle of February or so. Westerly anomalies in the Kelvin wave generation area, good for feeding the jet stream, good for storm production. Then a long run of the inactive phase is forecast from February 15th to about the end of March or so. Light westerly anomalies, probably a split jet stream pattern at that time frame. Probably not great for storm production. And then another building, pretty strong active phase of the MJO as we get into late March, early April time frame. Don't know if I'd believe a model going that far out, but something to keep in the back of your mind. Oh, low pass filter. Let's take a look at that. So this is basically like a giant low pressure bias. This is what all the hype was about El Nino, because we had this low pressure bias with 3 contour lines right over in the Kelvin wave generation area in the date line. And then somewhere in about December, everything just started falling apart. And it looked typically, notice when you get this stronger contour line pattern, the MJO gets very weak as El Nino starts building, but it fell apart. All of a sudden, the MJO starts waking back up, and that pretty much dooms the end of El Nino. So no El Nino for this year for sure. But the interesting part is, look at this. So the contour lines, they start retrograding as we get into April, and they're still in place. They tried to rebuild, they fade, but they don't dissipate at all. I mean, if you're going to get a La Nina, this would all be moving off to the east and dissipating. But no, supposed to hold over the Kelvin wave generation area as we get into April. And as you'll see as we get deeper into this forecast, what that potentially means. All right, enough on the MJO. What's going on in the ocean, okay? If you want to talk El Nino, La Nina, there's an atmospheric component, there's an MJO component, and there's an ocean component. All right? So this is data from the TAO buoy arrays, series of buoys strung across the equator. These are the anchor lines on those buoys. This is the East Pacific here. This is the West Pacific here. These X's are the sensors on the anchor lines. And from those sensors, you get temperature data. And then with a little bit of computer wizardry, you can try to connect the dots and build the pattern. And what do we have? Well, this is centigrade, 30-degree centigrade temperatures in the West Pacific, 28-degree isotherm line, pretty steep here, 165 west. It's actually retrograded. If you have El Nino, warm water is moving off to the east. When you see these sort of straight up and down isotherm lines here, that suggests no movement to the east. If anything, it suggests trades are sort of pushing and holding back the warm water from pushing to the east. Anyway, 24-degree isotherm, though still pushing into Ecuador, so all is not lost. Generally, it looks like warm water is trying to push east, just not very aggressively. And here, anomalies, differences from normal for this time of year. That sort of strips out the noise. And what do we have? Pocket of warm water pushing into Ecuador, 2 degrees centigrade, kind of weakening compared to last week. I think it was up to 3 degrees here. A little bit of a pocket of coolness here, maybe associated with the upwelling phase of the Kelvin wave cycle. New Kelvin wave developing under the date line, 4 degrees centigrade, we'll say 3+, and looking pretty good. Not super strong, but we certainly do not have anything that resembles La Nina here. No wholesale cold water anywhere. In fact, you see it looks like a river kind of flowing like this. That's typically what happens. You get westerly anomalies here in the Kelvin wave generation area. Westerly wind anomalies actually take warm water here in the west, push it to depth, and create literally this bubble of warm water is what's called a Kelvin wave. Then it traverses under the Pacific the whole way to Ecuador, and then erupts along the surface here. And then the trades start carrying it off towards Hawaii, south of Hawaii, and that's what creates the warm pool in the East Pacific, and that's the hallmark of El Nino. Another modeled version of that, just a different model, same raw data, basically saying the same thing. Kelvin wave building under the dateline. This would be the 3rd Kelvin wave of this supposed El Nino cycle. Kelvin wave number 2 fading out. Upwelling phase, cool pocket right here, presumably. So basically, the two models are in sync. Sea level anomalies. So this is JSON-2 satellite data. It's not actual temperatures. What it is sea height anomalies. These are 5 centimeters. We're talking, small little bumps on the ocean surface. So the JSON-2 satellites strip out the wave data, strip out wind waves, strip out the tides too. Remember, tides have effect. And what you see is a mapping of the sea surface height. We see a 10 centimeter bump right under the dateline. What's that mean? Well, that means probably warm water at depth. Warm water expands. It's what creates the bump. We see a warm water pattern strung the whole way across the equator, except for that -5 centimeter bump there. Remember, saw that cool water off of Ecuador, upwelling phase of the Kelvin wave cycle? That's what we think that is. But so the remnants of Kelvin wave number 2 right here, the Kelvin waves travel under the equator, directly under the equator. So if you get westerly anomalies here, it sucks warm water, actually pushes it out of the maritime continent north of New Guinea here, falls to depth right here, and then that thing, if you watch this for the next 3 months, it'll track slowly off to the east and eventually erupt somewhere over in here. You get enough of those and they're strong enough and big enough, then you get El Nino. And of course, the historical look. West Pacific here, East Pacific here. We're back a year, February, March last year. Cool water off the East Pacific. That was La Nina. Kelvin wave number 1 started in February, March of 2018. Eventually erupted over in Ecuador. It took, what was that, 4 months? 1, 2, 3, 4 months to make it the whole way across the Pacific into Ecuador. Upwelling phase of the Kelvin wave cycle. See that little cool bubble there? Kelvin wave number 2, much stronger, much bigger, generated by westerly winds in the late summer, fall of last year. That erupted, has been erupting. It's just now fading out. Here's your upwelling phase of the Kelvin wave cycle. And now here's our new developing Kelvin wave number 3 to start off January 2019. All right, so what's going on? We've talked MJO, we've talked subsurface temperatures. What's going on at the surface? All right, well, the big thing, here's Ecuador, here's the Galapagos. Last week we had pretty good warming in this area. It looks significantly decreased compared to weeks past, and even compared to months past. So the typical El Nino signal is like a big anvil of warm water going from Peru out to, south of Hawaii, then anviling up into Central America. Instead, we have this thin little weak pattern that's progressively getting weaker across the equator. A little bit of warm waters, though, holding, amazingly, off of Peru, and little pockets here and there, but nothing that looks strongly like El Nino. And then we go over towards the dateline region right here. Yeah, warm water the whole way north of New Guinea and into the maritime continent, but just nothing super El Nino looking. The trend for the past 7 days, light general warming off of Peru. We're seeing that, but a little bit of, you see these sporadic cooling, warming, hard to say, a little bit noise level, but no clear wholesale sign of some significant warming occurring. Probably this is that cool pocket subsurface, upwelling phase of the Kelvin wave cycle. Nothing to write home about here. And the overall trend, yes, light warming on the equator. You want to see this big anvil thing going on here. You kind of see a hint of it there and a hint of it there, but not strong, not even El Nino looking just from this angle. The temperature trend in the Nino 1.2 region, so this is the area just right off of Peru and Ecuador and the Galapagos. We got up, it's rather noisy in here too. I mean, it typically is. Today, 0.071, so dead neutral basically. You can see, yeah, it's been up, it's been down. The trend in general, if I just drew a line through it with my mind's eye, maybe half a degree above normal. That's not really El Nino. The official El Nino monitoring region, the Nino 3.4 area, from 120 west, so that'd be like south of California on the equator, out to 170 west or almost the dateline. You can see temperatures were warmer in this area, but it's slowly working its way down. Plus 4.25 tenths of a degree today. And if you just eyeballed it, I'd say the temps were like maybe 3/4 of a degree here, and and then they notched down to about half a degree, and now they're notching down to about 0.3 of a degree. That's not El Nino. You need 5 consecutive months of half a degree or higher anomalies. We're not anywhere close to that. No El Nino looking at the sea surface temperature data. But El Nino is not just Kelvin waves. It is not just sea surface temperatures. It's also, there's an atmospheric component. That is, the ocean has to warm, driven by Kelvin waves, and the Kelvin waves have to be created by active phases, the MJO and westerly wind bursts, right? But even after all that, the atmosphere above the ocean has to respond and the circulation has to change. One way of monitoring that is by the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When pressure is lower over Tahiti, this index goes negative. Today, it's minus 3.34, not particularly negative. It's only been negative 2 days, and you go back the past month and you see, yeah, it was a little negative there, but in general, this, not really negative looking. Averages out over 30 days, that takes some of the noise out of it. We're at minus 1.87. So even if you were having the active phase of the MJO, this guy should dip to like minus 8 or something like that. We're nowhere near there lately. The 90-day average way for monitoring El Nino, you want to see this guy down at like minus 10 or minus 15. Instead, we're at positive 2.77. So basically, no hint of El Nino in the atmosphere at all per this index. One other index, the ESPI index. Instead of measuring the difference in pressure between the area north of Darwin, Australia, and Tahiti, we measure absolute rainfall. If you have more rainfall in here, in this area, yeah, you see there's California there, and Peru and Ecuador are there, Galapagos there. So this is basically the official El Nino monitoring region, the 3.4 region. If you have warmer than normal water here, then you get more evaporation. You get more evaporation, you get more precipitation, and when you get more precipitation here, the index goes positive. But today it's 0.08, which is basically dead neutral, which means the atmosphere, there's no more precipitation here than there ever is, and it's just dead neutral. So no indication whatsoever of El Nino in this index either. And then the official CFS version 2 Nino 3.4 sea surface temperature anomaly forecast. So the solid line is verified data. Temperatures, sea surface temperatures in the Nino region were, what's that, 0.65 or 0.7, 3/4 of a degree above normal on January 1st. Okay. And this thing had been saying they were going to be up by 1 or even up to 1.25. So a little dose of reality here. And you got to have 5 months. So let's see. We've had of greater than half a degree above normal. So what do we got? September to October, November. What do we got? Maybe 4 months, 3.5 to 4 months of temperatures barely half a degree above normal, but no atmospheric response whatsoever. Anyway, the point being, the forecast has temperatures still slowly creeping up. And, winter, effectively from an El Nino perspective, is over. We're not getting El Nino this winter. But the more interesting thing is the forecast has temperatures rising to 1.15 degrees in April and 1.25 degrees in July and holding into October. Now, we're talking 8-9 months out. But per this model, no La Nina sort of thing. If anything, a continuation of this generic warm regime. We're actually hoping it doesn't get as warm as here, but that we get into a 3 or 4 year deal where we're hovering half a degree to 3/4 of a degree above normal, because that'll really get the jet stream going. It'll slowly change the global atmospheric circulation bias towards this kind of weak El Nino thing, and that's good. I mean, this winter, it hasn't been epic, but there have been swells, there's been surf, there's been snow. You look at the snowpack in the Sierra, it's, 110 or something percent of normal for this time of year, 120%. Things are doing pretty well, and we've been getting surf, and it has been bad, way better than it was for 2 years under La Nina. So all in all, things are shaping up to be pretty good here long term. So, to wrap things up, Not a bad situation. Series of swells coming towards Hawaii, U.S. West Coast. Local winds for Hawaii, not so good. Local winds for the U.S. West Coast when the stronger of the swells arrives, not so good. But a little bit of weather, rain, snow for California looking possible. So all in all, kind of a normal year shaping up. I think we'd say this was going to be a 6 out of a 10. 10 being the best possible winter you could have, a 0 or a 1 being the worst. And so a 6 is basically average, a little bit above average. That seems about where we're at for right now. We'll see how things play out over the next couple of months. But the general sense is, yeah, more surf, more snow. Can't be too bad. Pick and choose where you go. Be strategic. Use the models to pick the right spot for the right swell or the right snow or whatever. And long term, the outlook looking pretty good. Continued El Nino-ish long-term warm regime setting up maybe for the next year. Can't be bad. Anyway, that's it for this week. We'll do it again next week. Same time, same channel. Sure good to have my voice back, and we'll see you then. Thanks for watching.